Okay, here we go, YouTube Nation. We are dedicating today's lesson to Mr. Baller. So, yeah, pretty much. There he is. Take it in, folks. Okay. All right. So what do we want to do today? Same thing that we did yesterday, but opposite. So yesterday I gave you the equation. You wrote the graph. Today I give you the graph. You write the equation. We start with the parent function. What's the parent function for that guy? X squared. Tell me what kind of transformations are involved. Down 3, then vertical flip. So y equals x squared minus 3, because you say it's down 3, and the vertical flip means I put a negative out front. Good. Parent function for the next one. X cubed. Okay, you bring up a really good point here. I'm going to try to make this clear, okay? Shelby brings up something that I kind of want people to see, but we don't have time to teach everything in math, but I want you to see this piece right here, okay? I have y is equal to x cubed. And so you know what that parent function looks like. Watch this. If I go y is equal to negative x cubed, you would say that negative x cubed provides a vertical flip. Everybody agreed? You all good there? If I wanted a horizontal flip, I'd have to put the negative on the inside, correct? I would have y is equal to negative x quantity cubed. Hey, wait a minute. If I cube negative x, don't I just get negative x cubed? Right? I mean, it's the same thing. And if you think about it, if you took x cubed and instead of doing a vertical flip, if you did a horizontal flip, wouldn't you just get the same thing? Yeah, exactly. There are a number of functions when you do the vertical and horizontal flips, they are the same. And there's a special type of description for those type of functions. We're going to look at that later on. But that's why we really don't worry too much about the horizontal flip unless we get something like a square root function. That's where it really, really comes into play. So here we got x cubed. So we're going to go x cubed. We're going to do a vertical flip. We're going to keep it vertical, okay, unless we get to square root. So I'm going to go y is equal to, shift it back 3. So what do? X plus 3, quantity, cubed. Put a negative out front. Piece of cake, upside down. Next one, parent function, square root of x. So I'm back 3, so we got y is equal to, we already did that last one. We got x plus 3, so we know that's it. And then what? Plus 2. Sweet. We're rolling. Do you have these memorized? You need to memorize these functions. You need to know that x squared is a parabola, that x cubed looks like that square root function does that type of behavior. Uh-oh, let's get the difficult ones, 4, 5, and 6, then you can get to work on your own. Now I get challenging. What about this? 1 over x, close. 1 over x squared, why? Because they're adjacent quadrants. If they're opposite, then it's 1 over x. If they're the same quadrants, it's x squared. So we've got y is equal to 1 over, it looks like it shifted to the right, so x, whoop, stop that. X minus 2, quantity squared. Is there a vertical shift? Shift. There's no vertical shift. Is there a vertical flip? Yes. So you can put the negative out front, or you can put it on top, just as long as you have one negative. Good. So it's if they're in adjacent quadrants, then it's an even power. If you want to put x to the 4th, that would be fine. If you want to put x to the 6th, okay? Just have the idea that if it's even, they're in adjacent quadrants. Parent function for this guy. Third root of x, cubed root of x. So you can either raise x to 1/3, or you can raise cubed root of x. It's up to you. So it's back 3. We already did that. We got cubed root of x plus 3. What else do I got? Up to. Anything else? It is a vertical flip. You try the last one on your own. This one's challenging. Try the last one on your own. Give it some thought. Okay, awesome. Basically, everybody got it wrong. You had a lot of it right, but basically everybody wrong. I think Shelby was probably the only one that had it right. We're going to talk about her answer. We're going to talk about the most common answer. The most common answer is y is equal to the square root of x minus 6 minus 3. Now, I've harped on you about this, and I'm going to try to make a point again. Henrik Lane, first hour. Raise your hand if you know Henrik. Yeah, Henrik. So Henrik made a mistake, and that's part of what I love is that we all know Henrik's a good mathematician, right? Here's what makes him a good mathematician. He knew he made a mistake. How did he do it? He said, I know, it wasn't this problem, but let's pretend it was. He says, I know that 6, -3 is a point on that curve. So that means if I plug in 6, I should get -3 as a result, right? Okay? So watch. If I plug in 6, I should get -3. Plug in 6. 6 minus 6 is 0. Square root of 0 is 0, minus 3 is 3. So it works, doesn't it? But it's not right. Because watch. Would you agree that this graph, I should be able to plug 5 in as well and get an output? I'm going to plug 5 in. 5 minus 6 is, can I take square root of -1? No. So it's good to try to check a point and see what works. You see, there's a horizontal reflection here, isn't there? And so there's another way to write this so that 6 -3 works, and then we incorporate the horizontal reflection. We write 2 ways. First of all, y equals the square root of 6 minus x minus 3. That's the equation. Here's how Shelby wrote it. Y is equal to square root of x minus 6 minus 3, and then she put the negative here, which is the same thing, right? So she said, write 6, horizontal reflection, down 3. These are the two same, and that's how it is. Look at it now. It says I should be able to plug in 5 and get an output. If you plug in 5, 6 minus 5 is 1. Square root of 1 is 1, minus 3 is -2. It says, okay, I should have a point at 5, -2. And lo and behold, I do. So you should be able to determine those pieces and be able to do some checking. Did everybody, you guys did a great job coming up with the first part. Does everybody understand the horizontal reflection? Got to have that x negative. Whether you put the negative here and distribute through or whether it's here, they're the same thing. Good job.